Hi, Transitional Math students. We're going to work Practice Benchmark Chapter 9. Make sure you went through Chapter 9, all the lessons in the modules, in Canvas, in the videos. Chapter 9 is on linear functions. Linear meaning a line. So we're going to talk about what a function is, direct variation, graphing lines, and systems of equations that are lines, linear equations. So let's look at this first one. Determine whether each relation is a function. We're dealing with linear equations here, or linear functions. If I pick a line, let's say y equals 2x plus 5. I can tell if I have a function, and sometimes some people describe it as a box. I can tell if I have a function if my box is functional, meaning I put something into this box, an x value, let's say. I do the function to it and it spits out a y value. This box I say is functional if every time I put this x value into the box it gives me out the same y value. So for example, this is a function. When I plug in 2 into this function, I go 2 times 2 and I get 4, and then I add a 5 onto it and I get 9. So if this was my function, 2x plus 5, it would spit out 9. Okay. If I plug in 2 again, every time this will spit out 9, every single time. So this makes a function. Now if I had something in here that wasn't a function, if I plugged in 2 and it spit out 9, and I plugged in 2 again, and this time it changed its mind, it's going to spit out 7. Well, that's weird. That's not functional. I plug in 2, I get out 9. I plug in 2 again, this time I get out 7. So you can tell if something's a function if you have a set of ordered pairs and you repeat the x values, but you get different y values. Okay. Now, in a function, I can plug in 3 and get out 5. And then I could plug in 4 and get out 5. That's possible. That wouldn't be this particular function, but that is possible to get the same y value. Y values can repeat. That's okay. If the x value repeats, however, every time I plug that in, it better spit out the same answer. It can't change its mind. So if I plug in 2 and get out 7, the next time I plug in 2, I better get out 7 again, or I'm not functional. Now you can tell on a graph if I plug in 2 and get out 7. So when you're looking to see if something's a function, you look for the x values and see if they repeat. I have a -2, I have a 0, I have a 2, and I have a 3. I never repeated my x value, so I couldn't even tell to see if it's functional or not. These are all different x values. And I don't really care that the y value repeats. The y value is allowed to repeat. I can plug in 2 into my box and get out 0. I can plug 0 into my box and get out 0. As long as every time I plug in -2, I get out 0. And every time I plug in 0, I get out 0. It has to give me the same answer every time I ask it a question. Okay? I can plug in 2 and get out 0. That's fine, as long as every time I plug in 2, I get out 0. So the y value is allowed to repeat, just not the x value. So this relation is a function. Now let's go back to number 1 and see if this relation is a function. Now graphs are a little bit easier to test for functions. All you have to do is draw a vertical line. If you draw a vertical line and you only touch one point, anywhere on the graph, then you have a function. Now these vertical lines are only going to touch one point, but what about this vertical line right here? This one touches 3 points. So this is a no. This is not a function. And it's the same property because look, this point right here is the point over 0 up 1, 0, 1. This point right here is the point 0, -1. This point right here is the point 0, -2. So look, it's not functional because I take 0 and I plug it into my function and it spits out 1. I take 0 again and I ask it that same question, and this time it changes its mind and spits out -1. I take 0 a third time and it even gives me even another answer. It gives me -2. So this box is not functional. Every time I ask it the same question, it gives me a different answer. Not functional. The vertical line test tests for that. So with number 1, you can tell just with the vertical line test. If you draw a vertical line and you hit more than one point, you're not functional. And with the just a relation like this, you can tell by checking for your x values. Do any of your x values repeat? And here they do not. Y values are allowed to repeat, just not x values. So since they don't repeat, you have a function. Now if they did repeat, if I had another 2 here, let's say, I better get out 0 again. I better get the same answer. And it's the same point. Otherwise, it's not a function. I can't plug in 2 and get out a different answer. Okay, let's look at number 3. The relation, and here's the relation, we have 4 ordered pairs here, is not a function when which ordered pair is added to the set. So which one of these, when I add to this set, makes this not a function? So once again, I'm going to look for x values and see if they repeat. I plug in 2. I plug in -7, I plug in -4, I plug in 0. None of these x values repeat. Let's see here. -25, nope. 10, nope, none of these are a 10. 2, oh look, here's a 2. So if I plug in 2 and I get out 17, and I plug a 2 again, and this time it changes its mind and gives me out a 6, that would make this not a function. Okay, so this is the one that would make this not a function. 9, well none of these are 9, so 9 is fine. So this is the one. So what you want to look for is your x values. See if your x values repeat. If they do, check and make sure it tells you the same y value. 217 would be the same point and that would be okay. But 26, no. Okay, number 4, what is the value of f of -12 if f of x equals 4x minus 12? So this is in function form. Don't let f of x confuse you. It just means the function at x for a specific point. F of x in an equation form is just y. Okay, so all this means is I plug in -12 for x and I get out y. All right, and if you make an xy chart, you can make an x f of x chart. The function just allows us to be more specific. The exact point I'm plugging in is -12. So instead of saying y, I'm going to say the point I'm going to plug in here is -12. So I'm finding out the y value specifically at -12. So what I do is I take 4 times -12. Wherever there's an x, I plug in -12 and subtract off 12. Well, 4 times -12, what is that? -48. And then subtract off 12 from that. -48 minus -12, they're the same sign, so I actually add them and attach the sign. That's going to give me -60. So -60 is the solution when x is -12. It literally is just my y value. So in this form, I would look like this. I'm plugging in -12 for x, and the function at -12 gives me -60. It's the same here. I plug in -12 for x, and it gives me out, I lost my pen, it gives me out y, which is -60. So just remember, your f of x is just your y value. Okay. The function at -12 allows you to go, oh, I'm plugging in -12 for x, and that function specifically at -12 gives you out the value -60. Just think of it like y. All right, let's go ahead and look at number 5. Okay, number 5 goes back to lesson 9 too. When they give you some values and you plug them into the equations, now there's 4 equations in all these values, so which equation corresponds to the table of ordered pairs? A couple ways you could do this. Take your x value, each of your x values, and plug them into the equation, and then see if it gives you out this y value for each x value. So let's take this first one, 2, -3. Let's plug it into the first equation. We're going to plug in 2 for x and -3 for y. So it would look like this. -3 is our y value, equals And then the x value goes in here, so 2. And don't forget that negative on the outside, negative x, and then minus 1. So is this true? Does negative 3 equal negative times the 2 would make negative 2, minus 1 is negative 3. It is true. Okay, see if it works for this one. Plug in 2 for x and negative 3 for y. We're going to go negative 3 equals 3 halves. We plug in 2 for x, then subtract 1. Well, 3 halves times 2. The 2 on the numerator and the 2 on the denominator cancel, and I'm just left with 3. So this would look like negative 3 equals, I'm left with 3 minus 1, and 3 minus 1 is 2. So it's not this one. The first point doesn't even work in that one. Check it in this one. I plug in 2 for x and negative 3 for y. So I'm going to get negative 3 equals 2 for x, 2 minus 2. Well, does negative 3 equal 2 minus 2 is 0, so it doesn't work for that one. Plug that first point into this one. Negative 3 for y, so negative 3 equals 2 for x. We're going to go 2, negative 2/5 times x, which is 2. I plugged it in there, plus 2. All right, so multiplying, these can't cancel, so I have to multiply across the top. You can treat the denominator as 1. So this would look like this. Multiply across the top would give you negative 4 over 5. So this would be negative 4 over 5 plus 2. Well, negative 4 over 5 plus 2 does not equal negative 3. So not this one. This is our only one. Now I can check each point and see if each one of them works, but by process of elimination it has to be A. Check one more point just to double check. Plug in 3 for x and negative 4 for y. Careful with that negative, okay? So negative 4 goes in for y, so we're going to go negative 4 equals negative times whatever the x value is, which is 3, minus 1. Well, does negative 4 equal negative times 3, which is negative 3 minus 1? Well, yes, it does, because negative 4 equals negative 4. So you can check each of these points and make sure it works, but once you find one that works, check the other ones and see if one of the points work, and then by process of elimination, you can find your solution. Now, another way to do this whole lesson was on the equation of a line, y equals mx plus b. You can find your slope. Your slope is the change in the y's, y2 minus y1 over x2 minus x1. Okay, that's your slope. These all have a slope here. Here my slope is the number next to the x. So my slope here would be negative 1. My slope here would be 3 halves. My slope here, there's nothing written by the x, so it would just be 1. And the slope here is negative 2/5. So you can just go up to your chart and figure out the slope and see which one of these has the right slope. You don't have a constant rate of change here. 1 to 2, that goes up by 1. 3 to 5 goes up by 2. 5 to 6 goes up by 1. So it's not a constant rate of change. However, you can find the slope between any two y values and any two x values. Okay. So if these are two y values, I'm just going to go y minus y. So I go negative 4, careful of the double negatives. Remember, y2 minus y1, so the second y minus the first y. Negative 4 minus, and then the first y is negative 3, so a double negative, over x2 minus x1. So I do the second x minus the first x, 3 minus 2. Double negative makes a positive, so this looks like this. Negative 4 plus 3 gives me negative 1, and on the bottom, 3 minus 2 gives me 1. And negative 1 divided by 1 is just negative 1. So the slope for this chart would be negative 1, and once again, it would be A. So that's the other way you could do it if you don't want to plug in all of these points to see which ones of them work in which equation. All right, the nice thing is once one point works, double check a couple other points. You don't have to finish. And double check to make sure it doesn't work in these other ones, to make sure you didn't miss something. All right, so that number 5 on the test, double check it. Now this one said, what is the constant rate of change? Now remember, slope is the change in the y's over the change in the x's. Okay, you can do the same thing here. Subtract 2 of the y values and then subtract 2 of the x values. So 2 of the y values would be y2 minus y1 would look like this, 65 minus 60 over x2 minus x1, which would be 9 minus 8. Well, 65 minus 60 is 5, and then 9 minus 8 is 1, and 5 divided by 1 is just 5. So that constant rate of change, remember your rate of change is the same thing as slope. Slope is the rate of change, okay? Now because I have a constant rate of change here, I could have gone, well look, from 8 to 9 that's plus 1, from 9 to 10 that's plus 1, from 10 to 11 that's plus 1, from 60 to 65 that's plus 5. 65 to 70 plus 5, 70. So I do have a constant rate of change. So it doesn't matter which two I pick. I could pick these two or these two. The constant rate of change would be the change in the y's, which would be 5, over the change in the x's, which would be 1. So 5 over 1, which is the same as doing the subtraction I did between any two x's and any two y's. All right, and that's how you do it. Real quick, I just wanted to take note. Usually when the chart is on its side like this, the top number is the x and the bottom number is the y. And remember, slope is always the change in the y's. And I do that little symbol to mean change in the y's over the change in the x's. Okay, so y goes on top and x goes on bottom, but your chart usually has the opposite. So careful, this goes on top. So this would be the number of text messages per minute and the number of cell phones. So we ended up with 5 over 1. So 5 text messages per minute for every cell phone. That's what that means. That's your constant rate of change. All right, find the slope of the line that passes through these 2 points. Once again, slope is just the change in the y's over the change in the x's. Hold up. So you're just going to look at your x and y points. So if this is x1, y1, and if this is x2, y2, you're going to go y2 minus y1, so you're going to go -1 minus 2, and then x2 minus x1, which would be 5 minus, double negative here, -6. Careful of those. So 1 minus -2 is -3. 5 minus -6 will be the same as 5 plus 6. The double negative makes a positive, makes 11. So you're going to have -3 over 11, which would be B. Okay, number 8. What is the slope of a loading ramp that rises, so it goes up 3 inches for every horizontal change of 12 inches? Okay. So rise over run is slope. Remember, rise over run is slope. And if you're looking on an axis, if we made this be an axis, an XY axis, okay, if this is your Y axis and this is your X axis, remember, change in Y, you rise 3. Change in X, you run 12. You go up on the Y, over on the X. So it's a change in y over a change in x. Rise over run. So it would be 3 over 12. This reduces. If you can reduce, do. So 3 goes into 12 4 times, and 3 goes into 3 1 time. So 1 over 4 would be your final slope, which would be A. Instead of rising 3 and running 12, you could do shorter. You could rise 1, run 4. Rise 1, run 4, rise 1, run 4. Shorter steps. Either way, you're going to create that same line. Okay? And I didn't draw that very well, but either way you'll create, because this should have connected there. But yeah, either way you're going to create the same line. Okay, with those points. What is the slope of the line y equals to -3? Slope. Remember, y equals mx plus b. Okay. Where's your m? Where's your x? It looks like you just have b. This looks like this. Y equals to, and you just have the number -3. You don't have an x here. Where'd the x go? Well, the reason you don't have an x is because that number, that slope, is 0. 0 times x, or 0 times anything is just 0, and it leaves you just y equals to -3. So anytime you see a line of y equals 2 and the x is missing, that's because the slope is 0. If you're unsure, think about a graph of a line. Okay. Think about what y equals to 3 means. If this is y and this is x, and you have like 1, 2, 3, 4, -1, -2, -3, -4, 1, 2, 3, 4, -1, -2, -3, -4. Okay, where's y equal to -3? Well, on the y-axis, down 1, 2, 3, right here. If x was 1, y would be 3. If x was 2, y would be, -3. If x was 3, y would be -3. Y is always -3, so it's this flat line. And flat lines have a slope of 0. I always like to do this. Here's how you can know slope. If you go up a hill in your little buggy, if you go uphill, you have a positive slope. If you go downhill in your little buggy, from left to right, you have a negative slope. So if your line goes up, it's positive slope. If your line goes down, it's negative slope. If you're driving your buggy on a flat surface, you have 0 slope. It's 0. Now what happens if you try to drive your buggy straight up a vertical wall? That's not very vertical, but let's pretend like it is. Let's erase this. If you try to drive your buggy straight up a vertical wall, that's weird. How do I drive my car straight up a wall? This is undefined slope. And that's when you're going to have an x equals to something, a vertical line, okay? So when you have a y equals to something, y equals to -3, and you're missing that x value, you have 0 slope. You're a flat line, okay? Slope is 0. So remember, if that x value is missing and you just have y equal to a constant, your slope is 0. If you have an x equals to a constant, your slope is undefined. Okay, that would be an x equals to. Okay, the number of yards varies directly as the number of feet. Which equation can be used to convert x, which is feet, to y, which is yards? We know direct variation looks something like this. Y equals some constant times x. Y would equal x, except for there's some constant that changes that. It makes it bigger or smaller. But it varies directly. As x goes up, y goes up. As x goes down, y goes down by some amount. All right? So if we know yards, y was yards, and x is feet, okay, we know 1 yard is 3 feet. There's 3 feet in a yard, right? So 1 yard, that's supposed to be a y. 1 yard is 3 feet. So what I'm going to do is plug in 1 for y. I'm going to figure out what this value is. And I'm going to plug in 3 for x. 1 equals something times 3. To figure out what that something is, I solve for that m. Divide both sides by 3. Now we'll get 1/3 is m. Now I know what m is. I can come plug it in here and it will work for any number of feet to any number of yards. So my yards is going to equal, that m is 1/3. 1/3 times my number of feet. So for example, how many yards is 6 feet? Well, I would plug in 6 for x, and that yards, the number of yards would be 1/3 times 6. Well, 1/3 times 6 is the same as 6 divided by 3, which would be 2. So if there are 6 feet, that's 2 yards, and that makes sense because there are 3 feet for every yard. So if there's 6 feet, it would be 2 yards, right? So the answer here would be B. Okay, number 11, the cost of apples varies directly with the number of pounds of apples purchased. If you want the cost to be Y, or even a better variable might be C, okay, C for the cost. And then pounds could be P, or if you want, it could be X, depending on how you'd like to do it. I'd like to do C for cost and P for pounds, so I know what I'm looking at. So I know the cost varies directly, that variable would be M, we usually use, with the number of pounds, okay? I don't know how it varies, but I know the cost varies with the number of pounds because more pounds is going to cost me more money, right? So and then it says if 3 pounds of apples cost $3.90, so the cost would be $3.90, and that would be something, and I know the number of pounds is 3. So I can figure out how it varies. What is that constant of variation, okay? By plugging in 3 for pounds and $3.90 for the cost. That will tell me exactly how it varies. Solve for that constant. Solve for that m. And divide both sides by 3. So m equals, let's see, $3.90 divided by 3 is going to give me, that goes into that once, and that goes into that 3 times. So 1.3 or 1.30 if you're talking about money, $1.30. All right, so there's our constant. So now I can do it for any number of pounds. So the cost will be 1.3 or $1.30 times the number of pounds. So basically $1.30 a pound is what it costs. So what is the cost of 6 pounds of apples? That cost is going to be $1.30 times 6 pounds. And if I do 6 times $1.30, I'm going to get the cost is 7.8 or $7.80. You can put a 0 at the end. And 80 cents. C. All right, on to the next one. Which equation has a slope of 8 and a y-intercept of -5? Now, if I were to put this in slope-intercept form, that would be pretty basic. It would look like this. Y equals to mx plus b. Your m is your slope, also your constant rate of change. Your b is your y-intercept, where it touches the y-axis. If it has a slope of 8, this would look like this. Y equals to 8 times x plus my y-intercept would be -5. And you don't have to write plus -5, you could just write -5. All right, so there's my equation. Y equals to 8x minus 5. Now I come over here and I don't really see that. It's not y equals to -5/8x, no. It's not y equals to -5x plus 8, no. That changes around the slope and the y-intercept. Don't fall for that. Now, what about these two? They're not in this form. Well, can I put them in this form by solving for y? So I'm going to solve that first one for y. -8x plus y equals -5. If I solve for y, so that y is on one side like this is, I would add 8x to this side. And I would get y equals to 8x minus 5. Ding, 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 ding. So it is, whoops, I lost my pen. It is the first one, okay? You could solve this one for y. You would add 5x to this side and then divide by 8, and you're not going to get this equation. So it's A. So write up the equation. You know the form. Y equals mx plus b. This is your slope. This is your y-intercept. Plug it in and figure out which one of these is that. It was a little disguised because it wasn't solved for y, but it's right there. All right, number 13. A nail salon serviced 26 clients in a day for a total profit of $1,066. Manicures are $32. Pedicures are $45. If none of the clients had both services, which systems of equations represents this situation? Before we look at this, let's define some variables. Let's let m equal the number of manicures, so the number of manis. And then let's let p equal the number of pedicures, okay? That will be the number of pedicures. So if we have 26 clients, the number of manicures plus the number of pedicures is going to be 26. So set it up like that first, and then think of it logically. I made $1,066 that day. So that means I charged $32 for a manicure. So I'm going to go 32 times the number of manicures. Plus I charged 45 for pedicures. So I'm going to go 45 times the number of pedicures, and that's going to equal how much I made for the day. 32 times the number of manicures, $32 for a manicure, plus 45 bucks for a pedicure is the total amount I made. And the number of manicures plus the number of pedicures was 26 total. So there is a system of equations right there. Which one of these match that? 32 manicures plus 45 pedicures is $1,066. Manicure plus pedicure is 26, so it is A. All right, so just write it out. Remember, define your variable first, then come up and figure out, well, the number of manis plus the number of pedis was 26, and then figure out the cost. Think of it logically. If you were actually running a business, you charge $32 times the number of manicures plus $45 times the number of pedicures to get how much money you made for the day. All right, let's look at, and that would be gross, not net. Let's look at the intersection point of the graphs of the following systems of equations has an x-coordinate of 3 and a y-coordinate of 12. So here it is in xy form, all right? What information does this intersection point provide? So here's my system of equations, and it says 312 is the intersection point of the graphs. So that means on a graph at 1, 2, 3, up 12. 1, 2, 3. Okay, this is really, let's make 3 be right there. 1, 2, 3, up 12. This is really bad, and it's not to scale, obviously. So this point is where these two graphs intersect. Okay, it's a solution to the system of equations. So what information does this point provide? It provides the solution. That's all it's asking. It's simply asking you that. When you get an intersection point of the two graphs, you get the solution to the two graphs. You're basically telling me where these two graphs intersect is the point where they have in common. It works for both. So check it. Does it work for both? Plug in, we have the point 3, 12. Plug in 3 for x, 12 for y. So 12 minus 3. Does that equal 9? It does. Does it work here? Plug in 12 for y. So 12, does that equal 4 times 3? It does. 4 times 3 is 12. Okay, so 12 equals 12. So this point works for both of these equations. It's the solution of the system of equations. You don't have to do this part where you see if it works. It just wants to make sure you understand what the solution means. It means 312 is the point that works for both of these. So what information does the intersection point provide? It provides the solution. Okay. If the graphs never intersect, just so you know, if the graphs never intersect, they are parallel, and there's no solution. If a graph is on top of another graph, they intersect all the time, and the solution would be infinitely many solutions. They touch at all the points, every point you could think of. Okay? These never touch. Intersection, they touch at one point, which is your solution. All right, number 15. What ordered pair is the solution to this system of equations? So, which one of these ordered pairs works for this system? Well, just solve it. You have 2x minus y equals 4, and then you have x equals y plus 2. Usually you have to solve one of the equations for one of the variables, but this one's already solved for x, so use it. Take this is what x equals this amount, and plug it in for x into the first equation. So it looks like this, 2 times, and then instead of x, I write y plus 2. So I write this amount, y plus 2. I plug it in for x here. And that's right there. And then I still have to do the rest of my equation. Minus y equals 4. So I took this amount and plugged it in for x. Now I have one equation that has both y's. I can solve for one variable. I can't solve for two. So I'm going to distribute. 2 times y is 2y. 2 times 2 times 2 is 4. Then I subtract y equals to 4. Now I just do equation solving. Combine like terms. 2 y's minus one more y is just 1y. So I'm going to write 1y. So I have y plus 4 equals to 4. Now I can get rid of the 4 because I want to solve for y. So I subtract 4 from both sides. And I'm going to end up with y equals to 4 minus 4 is 0. Y is 0. So I found the y point. Now I have to figure out the x point. And I do that by coming over and plugging y, the value for y, into either of the equations. It's easier here because I can solve for x really quickly. So x equals to, you can plug y into this equation or this equation. We picked this one. X equals to 0 plus 2, so x will just equal 2. So I have x equals 2, y equals 0. As an ordered pair, that would be 2, 0. Remember, ordered pairs, x is first, y is second. Right? So 2, 0 is my solution, and that is B. Now, another way you could have done this without solving the system is plug each one of these into both of these and see if they work. If they work for both equations, then you know you have your solution. So you could have plugged in 3 for x and 2 for y and see if that's true. Then plug in 3 for x and 2 for y and see if this is true. If it works for both, it's not going to. Do it for this one. Plug in 2 for x and 0 for y. 2 times 2 is 4. 4 minus 0 is 4. 4 equals 4. It works. Plug in 2 for x and 0 for y. 2 would equal 2. It works. So that's another way you could do it. You'd have to do it for all of them. I say just solve it. All right, on to the next one. Okay, guys, don't be afraid of a little word problem. This problem is way easier than it looks, okay? Just read through it and think of it logically. An $890 computer. So you go to Costco, you buy a computer for $890. Over time, that computer is going to lose its value, right? It doesn't increase in value like a house. It just loses its value because a computer gets outdated or whatever. So you're going to spend this much on the computer. And you lose a value about $25 per month. That's the value of the computer going down each month. That's how much it's worth after a certain amount of time. This equation represents the value of the computer after X months, so $25 per month. So you're going to start out with $890 for the computer, then you're going to lose $25, and then X will be the number of months. That will be your value of your computer, okay? Identify and interpret. Identify and interpret two things, the X and Y intercepts. Explain how you can use the intercepts to help you graph the equation. Couple things to do. First way, identify and interpret. Okay, so the x-intercept, we find the x-intercept by plugging in y equals to 0. Okay, remember an x-intercept is where it touches the x-axis. That's the x-intercept. If you look at any kind of graph, here's an example. I'm just going to randomly draw a graph. All right. If you have an xy graph, in a random graph like this. All right, actually, let's make it be like this. Okay, here's a random graph. The x-intercept is where it touches the x-axis. And where it touches the x-axis, y is 0. So this might be the point, like -3 for x and 0 for y. The y-intercept here, x would be 0. So I go over 0, but I go up maybe 3, say. Okay. So to get the x-intercept, I make y be 0. So here's my equation. I'm going to make y be 0. 0 equals 890 minus 25x. Now solve for x. I'm going to, okay, erase that, I put it back. All right, so I'm going to come down here and solve for x. So I'm going to say, well, if 0 equals 890 minus 25x, solve for x, add 25x to this side to make it positive. So I'm going to add plus 25x to this side, to that side of the equation. Now I get 0 plus 25x, which is just 25x. That equals 890. And then to solve for x, I just divide both sides by 25. Now x is going to be 890 divided by 25, which gives you approximately, actually gives you 35.6. So the x-intercept, y is 0. So the x-intercept would be 35.6, and then the y point would be 0. Okay. So what does that mean? Let's talk about that in a second. Let's come over here and find the y-intercept. The y-intercept happens when x equals to 0. Okay, so we come over here to our equation again, and we find our y-intercept by letting x equal 0. Y equals 890 minus 25, x is 0, times 0. Well, 25 times 0 is just 0. 0, this makes 0 times anything makes it 0. So this goes away, and I just get y equals to 890. There's my y-intercept. So remember, x is 0, your y is 890. So my y-intercept would be 0 for x, 890 for y. Remember, y-intercept, x is 0. X-intercept, y is 0. So here's my x and y intercepts. I identified them. Let's interpret what that means. So what does that mean? Remember, our x was the number of months, okay? X is the number of months. So when x is 0, what this means is x is 0. So I would say at 0 months, or at the start, my computer's worth $890. $890 equals the worth of my computer. Okay, I'm just going to shorten that. $890 equals the worth of my computer. Now remember, x is the number of months, and what is y? Y is the worth of the computer. That's how much the computer is worth. It's the value of the computer. Okay, so the value of the computer, what if the value, y is 0? What if the value of your computer is 0? Well, that means a bunch of months went by. So what does this mean? When the value of the computer is 0, okay, value of computer is 0, then 35.6 months went by. So basically, at 35.6 months, my computer isn't worth anything anymore. Enough time has gone by that the computer is depreciated in value and new updates have happened and it's not really worth anything. So that's what that means. Remember, y was the value, x is the number of months. Okay, so when x is 0, when x was 0, before you even start, the computer is $890 of worth. When y is 0, the value is 0, 36.5 months went by. Okay. Now the last thing asks, explain how you can use the intercepts to help you graph the equation. Well, you only need 2 points to graph. So I would say this. You only need 2 points to graph a line. Okay, you don't have to graph it. It just says, explain how you can use intercepts to help you graph. Intercepts are points. This is 35.60 and this is 0,890. I only need 2 points to graph a line. 2 points make a line. Any 2 points, you connect them and you have a line. That's all you need. 2 points make a line. Okay. Let's look at this last one. The number of gallons of water left in a swimming pool at time t, okay, the time is t, can be modeled with this function. So we'll do this function, w, can't get it to work, hold on. W of t equals negative 7t plus 350. Find the y-intercept and explain what it represents in this situation. Okay, the y-intercept. Remember, we let x be 0. So instead of x, we have t. So let t equal 0. And instead of the y-intercept, we have a function. Remember, we can always replace our function formation with y. So let's write it like this. Y equals negative 7t plus 350. Okay, so in order to find the y-intercept, we let t or x be 0. So plug in 0, and then y is going to equal, if I plug in 0 for t, 0 times anything is 0, and I'm just going to get 350. Y equals 350. Here's our y-intercept, okay? So what does that mean? When the time is 0, When the time is 0, I have 350 gallons of water. That's what that means, okay? Well, what does that mean? It means I haven't drained my swimming pool yet at all, okay? So I still have 350 gallons of water. Y is 350. Number of gallons. V when no time passes. So it's just the number of gallons at the beginning. Time hasn't started yet. I start with 350 gallons. And that's how you do it, guys. Email me if you have any questions, and good luck.